In this video, we're going to take a look at topic 5.2, example 3. We're going to rewrite the product or quotient of a radical. So here we go with A. We have the fifth root of 16 times the fifth root of 8. Take notice here, my roots are the same. So what you're going to do is you'll just multiply the radicands. So here we can combine. We've got the fifth root of 16 times 8, which is the fifth root of 128. So now we want to simplify this. So again, I'm going to try to find factors of 128 where 1 is a perfect fifth root. So sometimes you might just have to play around with this a little bit, do some factoring. But we can write this as the fifth root of 32, which we know that one is 2, so that one we can simplify, times what's left is 4. And again, remember, 32 times 4 equals 128. And I have just picked these factors out because I know 32 is a perfect fifth root. So now I can simplify. The fifth root of 32 is 2, but I can't simplify the fifth root of 4. So that is just going to stay. That is a 5 there. Now take a look at B. Notice here we have an index of 6 and an index of 3. When your roots or your indices are not the same, you cannot just combine underneath the radical like we did in example A. So let's make a note. Roots are not the same. This takes a little bit more work. So I'm going to go ahead and move this into exponential form. It's actually going to make it a little easier to work with. So I'm going to have 8x raised to the 1/6 power times, my radicand is 2x, that becomes my base, raised to the 1/3 power. So we rewrote using rational exponents. So now we need to get a common index. And your index, remember, is the denominator of your rational exponent. So here, if I want a common denominator, I would need to multiply 1/3 by 2/2 to make this 2/6, which is equivalent to 1/3, but again, my indices are going to be the same. So now I'm going to have 8x raised to the 1/6 power times 2x, and again, I'm not going to show this, I'm just rewriting this fraction as 2/6. They are equivalent so that my denominators are the same. So here we need a common index, which is also, in our instance, the denominator. Now we're going to simplify. So what I'm going to do here, I'm going to factor out a 1/6. That's going to give me 8x times 2x squared raised to the 1/6 power. Now notice, if you were to redistribute this 1/6, you'd be multiplying your exponents. So if this is correct, you can always go back and double check. This would be 8x to the 1/6, which is what we had here. And we had 2x here. If I pull that 2 out, and again, if I'm multiplying, I would get 2x raised to the 2/6. So now, in here, I have 8x. Within your parentheses, you also have a power raised to a product here. So you need to distribute that 2 to both of your factors here. So this is going to be 2 squared, x squared, raised to the 1/6 power. 2 squared is 4. 8 times 4 is 32. X times x squared, remember, same base, add the exponents. This has an exponent of 1. So x times x squared is x to the 3rd. Raised to the 1/6. And now what I'm going to do is I'm going to move this back into radical form. So underneath the radical, I'm going to have what's in my parentheses, 32x to the 3rd. My index is 6, and my exponent is 1, and I don't need to show that. Here is our final answer, the 6th root of 32x to the 3rd. Now let's take a look here at rationalizing the denominator. So when we rationalize a denominator, we're rewriting it so that we don't have a radical in the denominator. So in order to rationalize this, we need to find a factor so that, in this instance, we have a cube root. We're going to want a cube root in the denominator so we can simplify that and get rid of the radical. So let's take a look. First thing I'm going to do, I'm going to break this up. I have the cube root of 2n in the numerator, and I can also write this as the cube root of 9m in the denominator. So now let's think. I want a perfect cube root. Let's just do this off to the side here. So here, if I were to factor this out, 9 is 3 times 3, and then I have an m. I need to force this into a perfect cube. So what is missing? Remember, if you're looking at an index of 3, when you factor your radicand out, you should see the same factor repeated however many times are in your index. So I am missing a 3. I am also missing 2 m's. So I need, what I'm going to need to do to force this into a perfect cube is I would need to multiply. So we are going to multiply by what we have here in red. I need 3m squared. And again, this would be the cube root. So this is what I have to multiply my numerator and denominator by in order to get a perfect cube in the denominator. I'm going to go ahead and let's rewrite this down here. I have the cube root of 2n all over the cube root of 9m. So I'm going to multiply numerator and denominator by the cube root of 3m squared. Now notice, I am multiplying same number over the same number. Any number over itself is 1. So again, I'm not changing the value of this at all. I am just rewriting it into a different representation so I can simplify it easier. So now when we do this multiplication, okay, and again, my index is the same, so I can just multiply whatever is under the radicand. Cube root of, I'm going to go ahead and spell this out, 2n times 3m squared all over the cube root of 9m times 3m squared. And now let's simplify. Cube root 2 times 3 is 6. I have an n and an m. My bases aren't the same. I'm going to write this as m squared n. Now in the denominator, I'm going to go ahead, let's just go ahead and we'll do this all the way. 9 times 3 is 27. M times m squared is m to the third. Now notice in my numerator, I can't simplify this. So it's going to stay 3, index of 3, cube root of 6m squared n all over. But now here, this can be reduced. The cube root of 27 is 3, and the cube root of m to the third is m.